All right. So, uh, howdy. Gonna be redoing Live 7 GNSS post-processing for the new Trimble data and some updates. So this video assumes that you already went outside, collected your data at the engineering quad, have your TO4 or TO2 files, uh, and you are already in the combustion stage. So if I click here, convert to Linux, this will open a web page from Trimble that will help me convert to Linux. So they're all their TO files and RT files. So you're gonna have either TO4 or TO2 files. So depending on which ones that you have, this this utility will do the work. So it should work perfectly fine. The one I the thing I want you to look at is this. You have to have the latest version of Trimble configuration utility as well for the Converter Linux to work. So if you click here, it will let you download that one as well. So you need both, not only one. So yeah, so download and install. So once you have done that, let's see, Converter Linux, you will get something like this. Uh, this is the conversion tool. So if I have a lot of files, I've set file, let's see. Yeah, so I'm gonna use the team2 file from section 5. So if I open this, you can see it gives me some uh, data about my file. The thing I want you to look at is up here. So if I click on file, on tool, sorry, option, I want you to select the latest Linux version. If you don't have this selected and get like a version 210 or 211, Opus will not recognize the file. So that's going to be a problem. So you have to click on the 3.04, the file, convert files, and it will give you, see what's that? So we'll give you, that was down. Yeah. So we'll give you several files. So we'll give you a 22.0 file, an N file, L file, G file, C. So we'll give you all of those files together. If I look into seven file, here I have a 22.0 file and a text file. So this is the two things that you have to do the post process. So the Trimble one has 10 points collected with RTK, and the 22 file is gonna look something like this. This is the Linux format. You can see about Linux version 3.4, and it has information about your point. So you should have one like that looks like this. The older format is gonna look different. So yeah, be mindful of that. uh, yeah, this should be also 22. Load the files to Opus. So if we go down to the Opus section, if you click on that link, it will open this. So in here you select your file. The antenna, it says is TRM 2 none. The elevation meters of your mark is 2 meters. The antenna height, you have to select 2 meters or type 2 meters. If you don't or select something else, your elevations will be off. So options, extended, let us choose. You have to add your email, and then use rapid static. And then you'll receive your Opus solution email. Your Opus solution email is gonna look something like this. So this is for that point. I show you the Linux file for. Um, yeah, it is. So yeah, it will have some information. that you need for the next fit. So go back here. So that's this. And you have to do that for the file that is provided and also for your own data. Okay. So something team. So it's the same settings that you use over here. And then convert to feet. You have to convert them to surveying feet. You cannot use because the email is everything is in meters, so you'll have to do that conversion. So RTK post processing. In the Canvas instance, you're going to find a template for this conversion. So what you're gonna do is grab information from another team. Team 2. Okay, this is the information from team 2. So the things that you have to use are you have to remember we use state plane coordinates 4203, and those are the nothing and is in the rules. So it would be these two are your good. These two are your nothing and is. Okay. In meters from the state plane 4203, Texas Central. And the elevation, that one is up here. So this one is the elevation height, 73 meters, and that's based on the reference frame from NAT 83 2011. So those are the ones that you have to use for this fit. So if I grab this too, so I'm only gonna do the null thing. The other ones are done exactly the same. So I'm gonna write it up here. Okay. But I don't need that in meters. Remember, this is in meters, but I don't need it in meters. I need it in survey US feet. So I have to do that conversion. So meter to survey feet. If I grab this number and I convert it to survey feet, I'll obtain a different number. So this is the number I have obtained. It should be around 10 million. It should be around 10 million. I was gonna say it depends. Like these numbers might change, but it should be around 10. So now, if I look for teams to points, I should have some. Okay, so I have team 2 points here. I'm sorry, it's getting cold. So I'm just gonna grab the eastings from these points. The easiest way to do this is if you open the text file in Excel and use the limited. The comma is the delimitator. Finish, and here we go. So I'm just gonna grab the null things. Here. So here he has 11. Some of you might have 10, some of you have 11, 12. It depends. So I'm just gonna get the difference between these two. That's that. And then square them. This one, align to 42, or whichever go. I don't need these ones. And this case, n equals 11. So just need the sum of these values. Then apply this formula. It's going to be the square root of the sum of b squared divided by n minus 1. So that's going to be my my root square error or standard deviation, the sample. So all of them should be done in the same way. So you have a sheet for north, for east, for elevation. So yep, that's kind of easy. So they should be really close, but you should still get a value of that error in there. So that's this. Download the data, do it. Remember to refer to this feed. So this is the data given to you. You have to do that, and then do the same thing with your 10 points and your 10 solution. Add both sets of results to tx. Now let's go to data analysis. Like I said, you can see here the distance between these two datums is around 100 meters in some places. So we have to see what differences with our points to these datums are, and see what the differences are to see which one's better to use. So if you click on this website, you should get this website. And what you have to do is input the stuff you obtained from, where is it? Uh, ba, 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 Team 2. Yeah, Team 2. I'm using, no. Yeah, I'm using Team 2. So what you have to do is give that website the information you got. So what you're gonna do, see it up here, go to the website, select XYZ, enter. It should be the RENX solutions. I didn't change it, I'm so sorry. RENX solutions, so this is the data you were given, and that is on Canvas as the XYZ coordinates. So I'm just gonna do that. So here, I'm gonna select XYZ, gonna give me an XYZ in meters. Now I can work in meters. I don't have to worry about conversions and stuff. And so I'm gonna grab the ones from the one I'm using, the current one, not 83 2011. And if you see, it says it right here. This is the one you're gonna use. So I'm just gonna copy the values here. Then y 889 and then 6. So if I leave them like that, you can see this little map went to somewhere in China, which is not quite right. So I'm going to add the binaries that it should have. Hopefully it will update soon. It sometimes takes a bit, and I'm going to reselect. Yeah, there we go. So it's in College Station, so that makes sense, right? We're going to let the zone be picked up on its own. You can go here and find the Texas one, but it's easier to open its own. And then you're going to select on this side the output reference to the ones that are in your list. So I'm gonna do first NAT 27, NAT 83 from 07, FBN, then on. So I'm just gonna select NAT 27. Then you have to click on submit for it to get processed, and you'll obtain something that looks like this. But if you go down here to customize export, you'll see that you can download it as an Excel file, a PDF file, a code file. You don't have to, because you can scroll through here. This was not here before, so you had to download it. You can scroll, and it will give you, as you can see, it has input lat, output lat, output, and then also input lat stuff. So it will give you the location in latitude and longitude. But what you actually need is the total distance between the points in US feet. So if you keep scrolling a bit, you can see that it gives you a long change, and before that is a lat change. So that's the the delta between the points in meters. You just have to apply the distance. So this is a triangle. You have one side and the other side. You just need the hypotenuse. So uh, you're just going to do that change squared plus long change squared square root, add them square root of that, and that will give you the total change in meters. But you need it in US feet, so you have to convert it, and then you'll obtain all of these values. So that's the data. So now to the report. In the Opus Canvas instance, you also have report template. So I highlight that because you have to change the date because that's not the date you're doing this. So Opus results. So you have to write down the results of your computations of the error for both things, for the RTK results that you took and for the stuff we gave you. And then it says add discussion. So you can add the table that you use with your results of the deviation, the points, but you need to add discussion and explain what does this mean. Datum, same thing. You need to provide the answers, but also describe what does this mean. So results is not only like showing, oh, I got this number, I got that, got that. It's telling people what does that, explaining that. Uh, so here you also like, please fill everything. So summarize the lab. What did you do at the lab? Look for the Trimble R2 antenna and summarize results. Add up a map of the points. You only have to do that for your point. And then you have the table results. Nothing is an elevation. The obtained root squares of both of them, well, of one, and then Trimble, and then your own point as tools here. Then the appendixes. What is Renex? You have to answer this question. What files comprise a Renex form? You have to fill this and add it, and then Appendix B. Optimize your summarize your opus results, and then add a screenshot of the first page of the emails. So there are several ways you can solve this problem. So that's it. So I hope it was clear. If not, I'll be in office hours, so you can attend those. So if you have any questions, or send me an email. That'll do. So yeah, have a nice